What if I told you that the universe we live in, everything we see and know, might be a kind of cosmic imposter? That it's all just temporary? It sounds like something from a movie, I know, but this is a very real question that physicists are grappling with right now. We're talking about a potential end to everything, an event that could literally rewrite reality itself.
So how would this cosmic do-over even happen? Well, it's a process called vacuum decay. And it's not a big explosion or a slow freeze. No, it's something much stranger. It's a bubble.
Just try to picture that for a second. A silent, perfectly spherical bubble of a new reality, expanding through ours at the speed of light. Anything it touches is instantly transformed. It's an idea so massive, it makes you question everything you thought was permanent.
Okay, so why would this even be a possibility? Where does this wild idea come from? Well, the answer lies in one of the most basic ingredients of our universe, the Higgs field.
You see, the vacuum of space isn't really empty. Not at all. It's buzzing with this invisible energy field, this cosmic soup called the Higgs field. It's what gives particles their mass. It's fundamental to our existence. But what if that foundation isn't as solid as we think?
And that brings us to this key idea, the false vacuum. Think of it this way. Imagine a ball resting in a little divot on the side of a huge hill. It looks stable, right? It's not rolling. But it's not at the very bottom of the hill, in the valley. It's in a metastable state. Stable for now, but not forever.
This graph here shows it perfectly. It's like the landscape of the Higgs field's energy. Now, our universe might be sitting right there in that first little dip, the one labeled phi 1. That's our false vacuum. But look over to the right. See that much deeper valley, phi 2? That's the true vacuum, the lowest, most stable energy state possible. And to get there, we'd have to get over that little hill in the middle.
So let's just lay it out. The true vacuum is the real deal. The lowest energy, absolutely stable, the ultimate ground state. But our universe? We might be living in a false vacuum, a cosmic imposter, just hanging out in a higher energy state, waiting for something to knock it over the edge.
So, what could do that? If we're the ball in that little divot on the hill, what could possibly give it the push it needs to roll down into the valley?
Well, the trigger is one of the weirdest and coolest things about quantum mechanics. It's called quantum tunneling. Basically, a tiny bit of the Higgs field doesn't need a push. It can just randomly and for no reason at all decide to appear on the other side of that energy hill. It just jumps.
A great way to wrap your head around this is to think about boiling water. Our false vacuum universe is like the superheated liquid, and these little pockets of true vacuum are like bubbles of steam starting to form inside it. It's literally a phase transition, just on the scale of the entire cosmos.
So let's trace the life of one of these universe-ending bubbles. First, quantum tunneling happens. A tiny little pocket of true vacuum pops into existence. Now, most of these would be too small and would just fizzle out. But, and this is the scary part, if one happens to form that's just big enough, the physics completely flips. It becomes more energy efficient for it to exist than not to. And at that moment, it becomes unstoppable. It expands outwards in almost the speed of light, changing the laws of physics as it goes.
I mean, this all sounds shockingly plausible when you break it down, which of course leads to the one question we all want to know the answer to. Is our universe actually in this fragile, metastable state? Are we just sitting here waiting for the bubble to pop up and end everything? Well, thankfully, scientists have been working on this. They've run the numbers.
And here's the verdict from our best theory of physics, the Standard Model. It looks like, yes, our vacuum is probably metastable. Now, the good news is its calculated lifetime is ridiculously long. We're talking trillions upon trillions of years longer than the universe has even been around. But here's the unsettling part. We are remarkably close to the line separating stability from instability. The final answer all comes down to the super precise masses of two tiny particles, the Higgs boson and the top quark. And we're still trying to nail those numbers down.
But wait, the story's not over. What if I told you that even if one of these lethal bubbles did form, the universe might have a built-in safety net?
This is such a cool twist. Some new research is suggesting that these bubbles of doom might not be a death sentence at all. In fact, they might just self-destruct.
So how would that work? Well, there are a few ideas. The bubble's own energy could create a back reaction that causes it to collapse in on itself. Or it could run into a kind of cosmic friction or drag that slows it down. And my favorite one, particles just floating in space could literally bounce off the bubble's wall, pushing back against it, maybe even stopping it in its tracks. The apocalypse could get stuck in cosmic traffic.
So, you have this amazing cosmic tug-of-war, a bubble trying to expand and rewrite reality, and the universe possibly fighting back. But, this isn't just some abstract idea on a chalkboard anymore. Get this. In 2021, scientists actually witnessed a type of vacuum decay, for real. They created their own false vacuum using a supercooled gas, and they watched as bubbles of the true vacuum formed inside it. They brought this incredible cosmic theory right down to Earth and saw it happen in a lab.
So, where does that leave us? After all of this, what's the bottom line? Are we safe? Or is the end of everything just a random quantum burp away?
Maybe the most terrifying part of this whole thing is that because the bubble expands at the speed of light, there's no warning. We would never, ever see it coming. 1 second you're here, and the next, there just wouldn't be a next.
And that leaves us right on the edge of one of the biggest questions in all of science. Is our home, our cosmos, a permanent, stable thing, or is it a fleeting state, destined to one day collapse? Right now we don't know. The answer is still out there, waiting to be discovered.